Today's tutorial, we're going to be building a scene with a warped ring that reacts to audio. For the audio, I'm going to be using a track from Ben Cheeky, who generously provided me with a bunch of his work. There is a link in the video description if you want to check out more of his music. I highly recommend it. Anyway, you can use whatever track you want as long as there's some sort of recognizable beat to it. We're going to be using RayTK version 0.41, so just make sure you're using at least that version. Check the video description for a download link for the toolkit. We're going to start by setting up our renderer and camera. Then we're going to create some ring-shaped SDFs and combine them to form a more interesting shape. Then we're going to use fields to vary the shifting of parts of the shape. Then we'll use modular material and surface color attributes to customize the appearance of the surface. Then we're going to set up some animation to get things moving, and we'll load in an audio source, and then finally we'll use audio analysis to find interesting parts of the signal and map those onto parameters in the scene. The first step is to load the RayTK Toolkit talks into your project. I like to do that at the root outside of the main project comp, but you can put it wherever you want. I do it out here instead of in the main project network, since that avoids having a lot of confusing data connection lines in the network, but you can put it wherever you want. Once that's loaded up, we can start building out the scene. Open the RayTK palette using the Alt-R shortcut, and then type in RayMarch Render 3D, and we're going to create one of those. And then drag out from the first output and create a null top so you can see the rendered image. With the renderer selected, use the Alt-Shift-R shortcut to open RayTK's Editor Tools menu. And then under Add Camera, we're going to choose Look at Camera. And we can keep all the settings on the camera at the defaults. Now that we have the renderer set up, we can move on to the SDFs that will define the contents of the scene. So open the palette again with Alt-R and create a torus SDF. And then connect that to the first input on the renderer. Torus, change the axis to Z, and then increase the radius up to 1, and then the thickness up a bit to around 0.3. Next, we'll combine that with a torus grid. Open the palette again and create a torus grid SDF. Select both of those operators, the torus and the torus grid, and open the editor tools again with Alt-Shift-R. And then under Combine SDFs, we're going to choose Simple Union, and then connect that combine up to the renderer. And I'm just going to rearrange the contents of the scene here, just move things out a little bit. Deal with weird network editor bugs. So now that we have the SDF set up here, so on the torus grid SDF, we're going to change the axis to Z to match the other one. And then we want to have the radius and the thickness match up between those two. So we can go over to the torus SDF and right-click its radius parameter, choose Copy Parameter, go over to the torus grid, right-click its radius parameter, and choose Paste Reference. And then we can do the same thing for the thickness. So copying from the torus SDF, and then pasting the reference onto the torus grid SDF. Then let's reduce the density of the grid there to spread out those dividing bars. So for the rows, we can do something like 4, and then columns, maybe 6. Next, let's make that combine a little bit more interesting. Over on the combine, instead of doing simple union, we can change the mode here to column union. And then drop that blend radius down to around 0.2. So that gives us this pattern there where the two surfaces merge into each other, creating those ridges there that are rounded out. It also gives us this offset parameter that we can use to shift that pattern of ridges. We're going to hook this up to audio later on. Next, let's make that torus grid a bit more exciting. So on the torus grid, we have the shift parameter. So try changing that, and you'll see how it shifts those bars along two different axes. So the first one goes kind of around the ring outer radius, and then the second one kind of spins it on that inner radius. So instead of just setting constant numbers there, let's use a field to vary that across different points in space. So open the palette, create a wave field, and then we're going to connect that up to the shift field input on the torus grid. And when you do that, make sure to mouse over the different inputs to make sure you're getting the right one, since the ordering of these inputs might change in different versions of the toolkit. So hooking that up to the shift field, we get some sort of result, but it's kind of a chaotic mess. So let's make some adjustments to fix that. So there's sort of two issues here. One is that it is just everything is being driven way too far in way too short of a distance. So to spread things out a bit for the period, we can increase that up to around 4. And even then, it's still being pushed way too far. And it's being applied the same to both of those axes of shifting, since the wave field here just produces a single number, and the torus grid allows you to use a field with a single number. It just uses the same value for both of the parts. But what we want is to have those be different from each other. So to do that, let's select the wave field, open the editor tools with Alt-Shift-R, and then we're going to choose Rescale as Vector, and then connect that Rescale field up to the torus grid. We can use this to choose how much it applies to the different parts of the axes, and it's only using the first two there since that shift only has 2 parts, but we can adjust these independently of each other. So for the first part, let's drop that down to around 0.1. And then for the second part, we can drop that down to around 0.3. Now we can go over to our wave field and try changing phase to see what that looks like shifting the pattern across there. We're going to add some animation to that later on. Now, before we get into the animation and the reactivity, let's set up a material and a light. We're going to be using a kind of standard setup with a modular material with diffuse and specular shading. So let's go over to the combine and select that. And we're going to open the editor tools menu with Alt-Shift-R, and then choose apply modular material. And then we can connect up that modular matte to the first input on the renderer. And when we do that, everything's going to go dark because we still need to set up some shading elements there. So with the modular matte selected, open the editor tools again with Alt-Shift-R, and then under Add Diffuse, we're going to choose Oren Nayar. And then select the modular matte again, open the editor tools, Alt-Shift-R, and under Add Specular, we're going to choose GGX. So this is a pretty standard combination that I tend to use in most of my scenes. To optimize things a little bit, so let's select both the diffuse and the specular contrib and open the editor tools with Alt-Shift-R. And then under lock parameter, we're going to choose method. So that will kind of bake that selection into the shader, which is going to optimize things a bit. If you're curious about what that does and why it helps, I recommend checking out the videos in the RightDK optimization series. And before we start dialing in the settings on the material, let's set up a light instead of using the default one that's built into the renderer. So select the Arraymarsh Render 3D and open the editor tools with Alt-Shift-R. And then under Add Light, we're going to choose Point Light. And dealing with weird network editor bugs. But now we can move on to Point Light And let's set up a position for that. So I'm going to move it sort of off to the side, about 5 on the X, up about 4 on the Y, and then back 5 on the Z. So that gives us some nice kind of variation in the shading in the different parts of the ring. Now that that's set up, we can move on to adjusting the properties of the material. So on the diffuse contrib, going to bring the albedo up to 1, and then increase the roughness a little bit to around maybe 0.6, 0.7. Then on the specular contrib, going to bring the roughness down a little bit to around 0.4, and then the Fresnel up to 0.8 or so. And on the specular, I'm also going to tint it to get a little bit of a variation in the shading. And for that, I'm going to go with kind of a orangey magenta color. And you can also do some different tinting on the diffuse if you want, but I'm just going to leave that as white. So that looks okay, but it would be nice if there's a little bit more variation in the color across the surface. So let's assign some surface color attributes to the two different SDFs that are making up the shape. Palette and create an assign color operator. And we're going to insert that between the torus SDF and the combine. And then we're going to do the same thing for this torus grid SDF. So create an assign color, and then insert that between the torus grid SDF and combine. Then we can pick the colors that we want for the two different parts. So for the torus, I'm going to go with kind of a light blue. That. And then for the grid, I'm going to go with more of a saturated orange there. And note that since there is other coloration being applied with specular shading and everything, we're not going to get like those exact colors showing up in here. They're more sort of like influencing the overall color rather than like explicitly setting it. Part of that is also because we are blending between those two SDFs. There's a little bit of a transition between the two colors there. So that's it for the contents and the visual style of the scene. So now it's time to move on to some animation, followed by audio reactivity. We're going to be animating the shift of the torus grid in two different ways. Because the shift feature on torus grid SDF supports using both a parameter and a field input, we can add some animation to the parameter for continuous motion. That'd be like that. And then also use the wave to provide that variation across space. So select the torus grid SDF, and then we're going to open the editor tools menu with Alt-Shift-R. And then under animate with speed, I'm going to choose shift and choose the top level one, not one of the individual parts. And that way we can animate both of them with just one speed generator. We can use the parts of that speed parameter to adjust how much it is moving on each axis. So I'm going to go with like 0.1 for the first one and then negative 0.2 for the second. And then you can use the speed multiplier there to kind of slow down or speed up the whole thing overall. So I'm going to go with around 0.5. Then we can go over to the wave that we're using to add to that shifting. So select that, open the editor tools with Alt-Shift-R, and then under animate with speed, we're going to choose phase. And for this one, we can keep the default settings for now. Later on, we're going to hook up audio reactivity to vary the speed there. Now it's time to set up the audio source that's going to drive the reactivity for the scene. I mentioned earlier that I'm going to be using a track from Ben Cheeky, but you can use whatever you want as long as there's some sort of recognizable beat to it. You could even use a microphone input instead of an audio file if you want. But if you are using an audio file, create an audio file in shop. And then we're going to locate wherever the file is and select that there. You could even stick with the default file if you want. The default demo file that comes with Touch Designer could be a good one just to experiment with if you don't have anything ready. To control the playback, you can either keep it on sequential play mode there, where it'll just always go wherever speed you set it, or you can lock it to a timeline. So if you want to give yourself a little bit more control, make it easier to jump around within the track, you can go with that option. So for that, you would go to play mode here, change that to lock to timeline. And then we want to make sure that our timeline length is as long as the audio file. So to do that, we can create an info chop and then drag the audio file chop onto it, and then middle click and look for the file length in frames. So for me, that is 11602. And then in the timeline panel at the bottom there, you can type that in 11602, and then do this for the end there, and then do it for the REND2, which is the end of the loop, 11602. So it will loop that full duration. So now you can jump around within the track using the timeline. You can delete the info chop if you don't want it anymore, or you can keep it there just in case you want to swap out the audio file, although you would still need to manually adjust the timeline length. If you are using a microphone input instead of an audio file, you would create an audio device in instead, and then just pick whichever the appropriate device is, and you would use that instead of this audio file in chop. To be able to hear the audio, create an audio device out chop, and then I'm just gonna drop the volume there before I hook it up. And on the device here, you would set that to whatever device you're going to be listening on. In this case, I'm using Voicemeeter as a way to be able to record that while also listening to it, but you will probably just use whatever headphones or speaker output you have. Then you can hook that up to your audio file in. And if you're using a microphone input, again, you probably want to make sure that you're not going to have a feedback loop there if you're using speakers and a microphone at the same time. But anyway, once that's in place, you can bring up the volume a little bit. So I'm going to keep this fairly low just so that you can still hear me while I'm talking. But if you're just working at home, bring that up to whatever level you want. Okay, so now that we have an audio source, we can start to analyze it to detect beats and also split it up into different frequency bands that we can use for controlling parameters. So easiest way to do that is to open Touch Designer's palette and then under Tools, go to Audio Analysis and drop one of those in. And then hook up the input to wherever your audio source is. Then we're going to drag out of the first output and create a null chop, and I'm going to call this audio vowels or audio values because we're going to be referencing that in a few different places. Since we're only going to be using a few of the channels that this produces, let's just drop in a select. You don't technically have to do this, but it'll just make it a little bit easier to see what's going on without having those extra channels listed there. So on the select, we're going to go to the channel names. We're going to pick low and high and kick. Then we just have those 3 channels. And then to get a little bit better of a view of what's going on there, you can drag out of that audio files and create a trail chop and set the window length up here, something like 30 seconds. And then you can open a viewer for that, or I'm just going to show it in this preview panel on the side here just to save screen space for the recording. But anyway, once that's up, one thing that you may notice here is that we're only really getting a signal on one of these channels. And that's because with the audio analysis component, you need to switch on the specific features that you want to have it detect. By default, only the low frequency band is active. So we want to go over to high active, want to switch that one on too, and then kick active, same thing there. And so I'm just going to jump to a different point in the track where there's a little bit more going on. This is one of those reasons why it's nice to have the timeline. Although if you do jump around, you may notice that the audio gets a little bit crunched up or distorted when you do that. So just make sure you're not doing that while you're recording or anything like that. So now that we have some data in there, let's kind of refine the settings there. So the specific settings that you use here are going to be different depending on what your audio is like. But one of the things that we can do here, or at least for the way that the audio that I have here, is for the high frequency band, we're not really getting a whole lot of signal most of the time. We are for some of the more busy parts, but each of these frequency bands has a threshold. So unless the audio signal goes above that, it just kind of stays at 0. So we get a lot of those kind of dead zones. So to make it a little bit more responsive, I'm just going to drop that down a bit to, maybe 0.1. And then for the kick, you can also adjust the threshold there if it's triggering too often or not often enough, or if it's like picking up things that aren't what you want to be listening to. For the kick, you can kind of adjust the threshold there to get it to only pop on when you want it to. So again, all this is going to be different depending on the specific audio that you're using. So I recommend taking a minute to just kind of pause the video and adjust things to get it where you're getting some good data on all 3 of those channels for whatever audio you've selected. Once you have things working well for your track, we can move on to mapping these analysis values to elements of the scene. We're going to be doing that in 3 different places. So first, we're going to use the low band to control the thickness of the bars in the torus grid. The first step there is to create a select chop. And I'm actually going to just bypass this audio device out so that it's a little bit easier to hear me, but feel free to keep it on if you want to keep listening while you're working on it. So creating this select chop, we're going to drag audio vowels onto it. And then under the channel name, we're going to choose low. And then for the rename to, I'm going to set that to something generic like level, or you could do channel 1 or something if you want. I find it to be helpful to do that rather than just like keeping it at whatever that original name is, so that you can swap out which channel it's coming from without having to like change any of the stuff that's further downstream of that. So anyway, once you've done that, you can drag out of that select and create a null chop. And then activate the viewer on that, go over to our torus grid, and then we can drag that channel onto the bar thickness, and then choose either chop reference or export. And then I'm going to switch back over to looking at the main render output there. Okay. So we're getting something there, but it is way too intense and way too fast. So we're going to need to make some adjustments there to those channels. So first, let's get the range into something a bit more reasonable. So create a math chop, and we're going to insert that between our select and the null. There are two different elements to the range that we want to deal with here. So the first is the range of values that are coming from the audio analysis, and then the second is the range of settings that we want for that parameter. So to get a sense of what those input ranges are, you can middle click on the trail here and then look at the range of the values for that low channel. So in this case, it's like right up, maxing out around 1.3, 1.4. So on the math chop, I'm going to go to the range here, and then I'm going to set the high end of that input range to, let's say, 1.4. Then we want to figure out what range we want for the parameter. And to do that, I'm just going to go over to the torus grid here, and then we're going to temporarily go back to just a manual value by just clicking on the slider and dragging it there. And so we can use this to kind of see what a good range is. I think something, let's see, around maybe 0.05 or so for the low end. And you can go over to math chop, and then for the lower end of the output range, you can go 0.05 or whatever value you want there. And then to find a good value for the upper end of that, just dial in there, and let's say right around 0.2 looks good. So we can go over to math chop and then change the high end of the output range to 0.2. And then we can go back over to the torus grid, expand the bar thickness parameter, and then go back to using the expression or export or whichever one you decided when you attach that channel to the parameter. So now we get a much more reasonable range of motion there, but it's still really kind of jittery and fast. So let's add some filtering to smooth it out a bit. To create a filter chop, and make sure to use filter, not audio filter. And we're going to insert that between the select and the math. You could also do it after the math if you want. It's not going to make a difference. And then for the filter width, we can drop that down to maybe 0.4. So we still get some motion there, and we can kind of tell when it's kicking on, but we don't get that really like sudden jittery motion. Next up, we can go over to our combine. And for this, we have that offset parameter, which shifts those ridges. So we can do something similar for that. So we can take that chain of chops, so the select, the filter, the math, and the null, just copy those and paste another copy of them. Then going to jump over here, right? And then for the null, just to open the activate the viewer there, go over to your combine, and then drag that level channel onto the offset and choose chop reference. And then we can go over to our select, and instead of using the low channel here, we can go to high instead, and then make sure you delete out the low so it's not doing both of them. And because we have that rename in there, we don't need to change anything about the expression that got put into the offset parameter there, since the name stayed the same. So similar to with the other channel, we want to figure out what the input range is. So you can middle click on that trail, and then looks like this one's going all the way up to like 6 or so. So on the math chop there, we can set the high end of that input range to around 6. And then for the output range, you can dial that in, and I'm going to put that to like around 0 to 0.3. And just jumping to a different point in the track that has a little bit more activity going on, we can start to see we get that motion there. And we can leave the filter width at 0.4, or you could, adjust that if you want, but I think it looks okay at that same setting. Then for the last part, we can use the kick to adjust the speed of the motion of the wave that's controlling the shift of that torus grid. So over here, we've got this speed generator here. And so by changing the speed there, we can make it go faster or slower. So we want to do that with the kick. And the kick is going to be a little bit different than the other two channels that we used, because those are just a level of audio, whereas the kick is something that kind of toggles on when it hits a threshold and then pops off again. So to do that, we're going to just make a copy of one of our selects that's grabbing from the audio vowels, and then for the channel name, we can delete wherever that was and then go to just kick, and then we can keep that rename again as it is, so we don't have to worry about where this is coming from and if we want to switch the source later on. For this one, we're just getting it kind of like blip on really briefly when the kick is detected. So what we want instead is to kind of like smooth that out a little bit. And one approach would be to use the filter like we did for the other channels. But I think a better approach here is to use a trigger chop. So let's create one of those, and we can connect the select up to that. So then on the trigger chop, we can go to the attack page and then drop the attack length up a little bit to maybe 0.06 or so. So it kicks on a little bit faster, but you still get a little bit of a ramp up there. Then over on the sustain page, we can drop the decay length down to around 0.1 and bump the sustain level up to 1, so that is the value that it stays on until it drops back off. So instead of going like all the way up to 1 and then dropping to half for a bit and then going down, it just stays at 1. And then for the decay length, or no, we already adjusted decay length, so then I think the least length looks okay there. So it kind of like pops on pretty quickly and then drops down a little bit more gradually. Then we want to do something similar to what we did with the other channels with math chop. So create one of those. And we know what the input range here is going to be. It's always going to be 0 to 1. But the output range is what we want to configure. So let's first just drop down another null at the end of that. And then we can go to the speed generator and look to see what a good range is here. So if we go like negative 0.2, that gets it moving in one direction, and then faster in the other to maybe like positive 0.7. So then over on the math chop, we can adjust the output range there to negative 0.2 and 0.7. And then we can take the channel from that null and drag it onto the first speed parameter and choose chop reference or export if you want. And that way we also get still a slider here that we can use to kind of tune it. So by having one end of that range negative and the other one positive, it will kind of reverse direction and speed up whenever that kick happens, which I think is kind of a nice effect. And that's it for the scene. So to recap, we are using a combination of a torus SDF and a torus grid SDF. And We are linking the radius and thickness of the two of those so that they always kind of line up with each other. We are combining them with the column union combine mode, which adds those ridges between the two. We are assigning surface color attributes to get some different coloring on the different parts. We're using a modular material with diffuse and specular shading. And then we are taking an audio source, either an audio file or microphone input. We are running that through the audio analysis component from Touch Designer's palette, grabbing the specific channels that we want. And remember that on the audio analysis, we hit switch on the channels that we want to use to make sure that it is actively tracking those. Then we take the different channels that we want and apply some filtering to smooth them, math to scale them, and then mapping those onto parameters. And then we're doing something similar for the speed of one of those waves, where for the kick, we're using a trigger chop to get it to kind of gradually pop on and then drop back off again. So it adjusts the speed by kind of switching directions and speeding up a bit and then dropping back to the other direction. There are lots of different things that you could do with the scene from here. Obviously, you can swap in different music, although you're going to need to refine the settings on the ranges for that if you do that. And you could try different kinds of transformations or distortions on the combined shape after it's combined, or even before and on individual parts of it. You could use, a field to vary the color of different parts of that, or use a different combine mode to change how that blending between the two happens, or lots of other things. Anyway, I look forward to seeing what you all do with this, and if you post on social media, use the RayTK hashtag. And at least on Instagram, you can tag me personally if you want to show off your work, because their hashtag search is not great, and I may not see stuff if it just has the RayTK hashtag. Anyways, thanks for watching. And if you want to support RayTK development, subscribe to my Patreon. You'll get early access to tutorials, exclusive scene file downloads, and a bunch of other stuff. And even if you don't want to pay, you can still subscribe there for free as a way to get announcements about the toolkit. Feel free to reach out if you have any questions. I'll put links in the video description for different ways to reach me. Thanks for watching, and as always, make sure to like and subscribe.